Hey guys, this is Mrs. Harbin, and we are continuing with Unit 7, all about radicals and exponents. Today we are looking at products of radical and exponential expressions. Let's start with a quick warm-up and simplify these radical and exponential expressions. Now the first one, we could go ahead and multiply 9 times 25 and get 225. But if you don't know the square root of 225, it might be easier to apply the product property of radicals. And the product property of radicals says that I can rewrite this as the square root of 9 times the square root of 25. So I can apply that radical symbol to both of my factors and have it written this way. Now I know this might be a little bit easier to do because the square root of 9 is 3, and the square root of 25 is 5, so I'm left with 3 times 5, or 15. So the square root of 225 is in fact 15. X to the 4/3 times x to the 5/3. According to my properties of exponents, if I have the same base, I can just add my exponents here. Remember, let's do one not fractions. If I have x squared and x cubed, that's 2x's being multiplied here and 3x's being multiplied by here. So that's x being multiplied by itself repeatedly 5 times. So x to the 5th. I just added my exponents, and I can do that here as well. So 4/3 plus 5/3 equals 9/3. So x to the 9/3, which can be simplified as x cubed. X to the 9/3 is x cubed. What about here? 2 to the x plus 1 times 2 to the 3x plus 1. What can I do here? Well, just like before, my bases are the same, and so I can add my exponents here. And when I add x plus 1 plus 3x minus 1, I get just 4x. So my base stays the same. This is the number that I'm multiplying, 2, and then my exponent is what changes. Again, I'll say this, I've said it in multiple lessons, and I'll say it again. You need to have a very good understanding of the properties of exponents. You need to be able to switch between exponents and radicals and be able to switch back and forth between those two forms. Now, we're going to do a lot of that in class, a lot of practice in our warm-up. But you also need to dedicate some time to learning and practicing those properties of exponents. Our lesson objective for today is that you, the student, will multiply radical expressions and exponential expressions. So in the previous lesson, we learned how to add and subtract our like terms, our like radicals and our like exponents. Now we're going to multiply those radical and exponential expressions. I mentioned it already in the first part of this lesson, but the product property is used to simplify radicals, and it also allows us to simplify many products of radicals. Because I know the root of x plus the root of y is the same as, the root of x times the root of y is the same as the root of x times y. And this could be the square root or the cubed root. You saw at the beginning I had 9 times 25, and I actually went this way and broke it apart into 2 roots. And that allowed me to simplify that. So don't forget about the product property. This works with multiplication. Remember, we can't add radicals unless they have the same radicand. Just like we can't add x plus y unless they have the same exponent or the same variable. We can multiply x times y, and we can multiply 2 different radicals with different radicands. Okay, so very, very similar there when we're talking about like terms and radicals. All right, let's take a look at this example. We have the square root of 6 times the square root of 8. Now, neither one of these is perfect squares. So it's not like the example at the beginning where we just had 3 times 5. And so what we want to do, we can go about solving this 2 ways. We're going to take a look first at multiplying them. So we're going to use the product property to rewrite that as the square root of 6 times 8. 6 times 8 is 48, but if we do the prime factorization, what we get is 2 times 3 times 2 times 2 times 2, or 2 times 2 times 2 times 2 times 3. We do the whole prime factorization. We are taking the square root, so we're looking for groups of 2. So I can rewrite that as 2 squared times 2 squared times 3. The square root of 2 squared, or the square root of 2 to the 4th there, is 2 squared, because I would take the square root of each individual part then. Square root of 2 squared is 2. The square root of 2 squared is 2. And the square root of 3 is square root of 3. So we have 2 times 2, or 2 squared times the square root of 3. So it can be written a lot of different ways here. And when we simplify that, we get 4 square root of 3. Now, if you wanted to do that a different way, I'm going to try the different way down here, make sure I have enough room. Let's see if we can simplify this here. So I can't simplify 6 because that's just 2 times 3, but 8 is 4 times 2. And I know 4 is a perfect square, so I can rewrite that as 4 square root of 2. And then when I multiply, I'm going to have 1 square root of 6 times 4 square root of 2, or 4 square root of 12. And then my 12 is made up of 2 square roots. Sorry, the square root of 4 is 2. 2 square root of 12. And then 12 is 4 times 3, so I have 2 times the square root of 4 times the square root of 3, or 2 times 2 times the square root of 3, and we still get 4 square root of 3. So there are 2 different ways you could do that. You could simplify your radicals first and then multiply, or you can multiply and use prime factorization to simplify your radicals. So multiple paths that you can take to simplify this radical. Let's try to simplify this one. 2 cubed root of 4x squared times 5 cubed root of 16x. Now what I'm going to do here is actually multiply the 2 and the 5, and then multiply my 2 radicands together. So we get 2 times 5 on the outside, and the cubed root of 4x squared plus 16x. Our prime factorization would have 2 times 2 times 2 times 2 times 2 times 2, and then x times x times x. Because we're looking for the cubed root, we're looking for groups of 3. So we have 2 cubed and 2 cubed and x cubed. And we then take the cubed root of each of those. Cubed root of 2 cubed is 2. Cubed root of 2 cubed is 2. And the cubed root of x cubed is x. And you'll see that it's written a little bit differently here in the example. This is just another way to write it. 4 is 2 squared and x squared. 16 is 2 to the 4th and x. We can then combine our base 2's and our base x's here. So 2 squared and 2 to the 4th is 2 to the 6th. X squared and x to the 1st is x cubed. And then that's simplified from there. So I have, if you remember, 2 times x, which is 2 squared x, and they have 2 squared x. So you see we have the same thing here with our original 10, 2 times 5 that we have. And now we can simplify this one more time. We have 2 squared is 4, so this could be written as 4x. And then 10 times 4x is 40x. Hey, again, if you don't like that multiplication dot, you can use parentheses there if that works better for you. So this one simplified is 40x. The commutative, associative, and distributive properties hold true for complex numbers. But the product property of radicals cannot be applied to negative radicands of even roots. So the product property says, for example, that I can take square root of 6 times the square root of 8, and that's equal to the square root of 48. It does not work with negative radicands of even roots. So if I did the square root of negative 1 times the square root of negative 1, that does not equal the square root of 1. Negative 1 times negative 1 is positive 1, and that does not work. Because we know the square root of negative 1 is I, square root of negative 1 is I, but that equals is I squared. And I squared is actually negative 1. So the product property does not work or apply to negative radicands of even roots. So let's try to simplify then some negative radicands with even roots. We've got the square root of negative 6 times the square root of negative 21. What we want to do before we try to simplify these is rewrite these so that they have positive radicands. And the way that we do that is by taking our square root of negative 1 out of each of these radical expressions, and the square root of negative 1 is I, so we're going to rewrite that as I square root of 6 times I square root of 21. We'll then multiply what we have here. I times I is I squared, and square root of 6 times square root of 21, square root of 6 times square root of 21. We can use whatever simplification method we prefer. That could be prime factorization, it could be looking for perfect squares, but we're going to simplify that 6 times 21, and we have 2 times 3 times 3 times 7, or 2 times 3 squared times 7. We'll then take the square root of each of these, and the only one that actually can be simplified using a square root is 3 squared. Square root of 3 squared is 3. So we have negative 1 times 3 times the square root of 2 times the square root of 7, which is negative 3 square root of 14. The distributive property and the FOIL method can be used to multiply radical expressions. So we're going to try one where you have to distribute a radical to simplify. Let's simplify this problem. 2 root 3 times 1 plus 3 root 6 minus 6 root 3. To get rid of those parentheses, we are going to distribute this 2 root 3 to each term. So 2 root 3 times 1 is just 2 root 3. 2 root 3 times positive 3 root 6. 2 times 3 is 6. And 3 times 6 is 18. So we have 6 square root of 18. And then square root of 18 can be simplified some more here. Square root of 18 can be written as 18 root 2 by using prime factorization and pulling out any perfect squares. And then 2 root 3 times negative 6 square root of 3. We have negative 12 square root of 9, but 9 is a perfect square. The square root of 9 is 3, so we get 12 times 3, which is 36. So 2 square root of 3 plus 18 square root of 2 minus 36. There's nothing else that we can do to simplify those expressions, so we don't have any more like terms to combine, and that is our simplified answer. Here we have binomials, and our binomials have some radicals in them, but we know the process for multiplying binomials is foiling. Some of you like the box method or other methods. You can use those as well, but we're going to go ahead and multiply our first terms. 5x times 2x is 10x squared. Our outside terms, 5x times negative 3 root 2, negative 15x root 2, and our inside terms, 2x times 1 root 2, so 2x root 2, and then our final terms, root 2 times negative 3 root 2, which is going to give us negative 3 root 4, and the square root of 4 is 2, so negative 3 times the square root of 4 is negative 3 times 2, which is simplified here, negative 6. So I kind of did a step in between there. We can combine our two middle terms here, negative 15x root 2 and positive 2x root 2. Our root 2 stays the same, and all we're doing is combining the rational coefficients. So negative 15x plus 2 is negative 13x. And now we don't have any terms that are the same. We have no like terms, and we are finished simplifying this problem. Let's try to simplify 1 plus 3i times 2 minus 5i. Using foiling here, I may run out of time and have to do a part 2, but first, outside, inside, last, and then we'll combine our like terms, but don't forget I squared is just negative 1. We combined our middle terms and we substituted that for negative 1. I squared is negative 1. And when we simplify again, we get 17 plus I. All right, how would we simplify this one? Think about that, and we'll take a look at the answer in part 2.